Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Amiruddin Berman Azim. I am from UC Tati, and today I want to share about impact of cross-linking on conductivity of polyvinyl alcohol membrane. Okay, first and foremost, we go to the problem statement. Lithium battery ion has a limited lifespan and need to be replaced, which affect the massive application of portable consumer electronic device. Polyvinyl alcohol membrane naturally possesses lower conductivity value that significantly reduce the performance. For this reason, this study is conducted to investigate the potential of cross-link agent to increase the conductivity of polyvinyl alcohol-based membrane and make a high-performance solid polymer electrolyte. Okay, next we go to the objective of the study. First is to prepare polyvinyl alcohol-based membrane with cross-linking effect and potassium hydroxide to investigate cross-linking effect which is on polyvinyl alcohol-based membrane. And lastly is to characterize the polyvinyl alcohol, polyethylene glycol, and graphene-based membrane. For the methodology, we have three steps here, which are preparation of alkaline membrane, cross-link immersion solution, and lastly is bath of potassium hydroxide. For every step, we have testing, which are EIS, DSC, and FTIR testing. Okay, for this study, we have three samples, which are first is polyvinyl alcohol, second is polyvinyl alcohol plus polyethylene glycol, and lastly is polyvinyl alcohol plus polyethylene glycol and plus graphene. Okay, first is preparation of alkaline membrane for polyvinyl alcohol. For the polyvinyl alcohol, we have two samples here, which are 5 gram and 10 gram of polyvinyl alcohol. We mix all them together and we stir and mix for 4 hours. And after 4 hours, we cast on the pantry dish, and after 1 day, we can peel off the membrane. Okay, second is crosslink immersion solution. We mix glutathione, hydrochloric acid, and acetone. And after that, we took the solution and the membrane in the glass container and we close for 40 minutes. And after 40 minutes, we can see the size of the membrane become bigger. And last is bath of potassium hydroxide. For this, we mix water and potassium hydroxide, and after that, we transfer the solution and the membrane in the glass container, and we heat for 3 hours, 60 degrees Celsius. And after that, we pick the best conductivity, which are either 5 gram or 10 gram of polyvinyl alcohol. Okay, for the preparation of alkaline membrane for polyvinyl alcohol plus polyethylene glycol, for this we choose the 5 gram of polyvinyl alcohol because 5 gram of polyvinyl alcohol more conductive than 10 gram of polyvinyl alcohol. And after that, we mix with polyethylene glycol. For polyethylene glycol, we have 5 samples here, which are 2, 4, 6, 8, and 10. And we mix all together and we stir and heat for 4 hours. After 4 hours, we cast on the pantry dish for 1 day, and after 1 day, we can peel off the membrane. And second is crosslink immersion solution. For this solution, we combine glutathione, hydrochloric acid, and acetone, and we transfer the solution and the membrane in the glass container, and we close for 40 minutes. And after 40 minutes, the size of the membrane become bigger. And last is bath of potassium hydroxide. Same as before, we mix water and potassium hydroxide, and we transfer the solution and the membrane in the glass container, heat for 3 hours, 60 degrees Celsius. And lastly, we choose the best conductivity. And lastly, for the preparation of alkaline membrane for polyvinyl alcohol plus polyethylene glycol plus graphene, we choose 4 gram of polyethylene glycol because 4 gram polyethylene glycol more conductive than others. And then we mix it with polyvinyl alcohol and 1 gram of graphene, and we stir and heat for 4 hours. And after 4 hours, we cast on the pantry dish, and after 1 day we can peel off the membrane. And second, we go to the crosslink immersion solution. we mix glutathione, hydrochloric acid, and acetone. And after that, we transfer the solution and the membrane into the glass container and we close for 40 minutes. And lastly, we can see the membrane become bigger. And lastly, for bath of potassium hydroxide, we mix water and potassium hydroxide, then we transfer solution and the membrane in the glass container for 3 hours and degree Celsius we heat. And lastly, we can choose the best conductivity. Okay, this is the picture from our study. Okay, this is the membrane after peel off. This is the Gosling immersion solution step, and this is the membrane after soak with glutathione, acetone, and HCl for the bath of potassium hydroxide. And this is the last product that we got. For the result, this is the result of polyvinyl alcohol. We can see here, 5 grams of polyvinyl alcohol more conductive than 10 grams of polyvinyl alcohol. Okay, next is the result of polyvinyl alcohol plus polyethylene glycol, which is we can see here that 4 grams of polyethylene glycol more conductive than 2 grams. And lastly, this is the result for polyvinyl alcohol plus polyethylene glycol plus graphene. And we can see here the last product that we got conductivity is 1.89 exponent negative 5. And lastly, for the conclusion, cross-linking polyvinyl alcohol with glutathione can improve the conductivity of polyvinyl alcohol up to 1.89 exponent negative 5 SCM in order to make a high-performance solid polymer electrolyte. That's all from me.